All right. So now jump into part two of lab one. Is this step rod? So you're going to have a few questions related to the finishing, but you're going to see that on the lab. So right now, what I'm going to show you is how you can just work this part as with the first part of lab number one. It's going to be part of your pre-work for the lab to do the calculations of the motion to obtain the depth and reduce this much material from the original diameter that it's 0.75 inches. Okay, so we need to have this stepped rod. We need to reduce to initially to 0.7 and then reduce to 0.6 and then reduce it to 0.5 on these lengths. All right, so there are going to be also some questions about these dimensions. In this case, just to make it fair, because not everyone has taken the same courses. So this means that all of our measurements should be obtained from this reference. But due to how we're going to make it, we're gonna have the facing and then try to obtain the dimensions from this point to the back. Okay. The best case scenario would be to have the part like kind of backwards, but to avoid any issues with the bearings and alignment that we could have with the lathes that we're using, we're just going to do it as it is. All right. So the best practice would be just to make the marks from this line, obtain these positions, and then start cutting the material. But for the purpose of the lab, is just showing you how to use these operations. We're going to do it as I'm going to show you. All right. So the first step would be to have facing of this side of the rod, and then drill the center hole. All right. So facing is already operation that we did, and doing the center drill, I'm just going to show it again, but it's going to be part of the things that you already did in the first lab. All right. So for that, we are going to need to use the holder. Again, use the 3mm drill bit, and then place it over here, as we did it with the previous lab. Okay. Hope that looks better. Okay, so as we did it before, let's place this element right here. Let's bring it closer. As you can tell, we already face this surface. Okay, and what we're going to do is try to get because I'm using the previous the material stock that we used for lab number one, just to have like a remainder of the holes that we did to obtain the ring. But let's just make one just particular for this. Facing is already covered, so let me just lock this, get this closer, right there. Try to add some oil to avoid any damage on mainly on the tools. And again, let's make it run to around 500 RPMs. Bring it in and out. Alright, and I think that'll do it. Okay, so we're good with this part. Let's bring this out. and remove the central lead bit. Okay. So now the next step is to do the measurements that we need for our part. So in order to do that, we're going to need to bring the material stock out. So far, in order to do that, again, is removing as the same procedure that we did to place it in the chuck. It's going to be just backwards. Okay, just bring it out. And this is pretty much the material stock that we had from the first video, that it was just cutting the material. So overall, we're looking for 3 1/4 inch of length. So I think we have enough material to do this. Okay. So we had enough material. Let's just try to get this close to that mark. All right. Okay, so that means that we're going to do this in steppings. So just to keep in mind that that is the length, and probably to mark it. Okay, right there. That's going to be my reference. So we have all this material extra. This is mainly because, as I indicated in the first video, we are going to use almost 8 inches of material for the 3 parts. So what we're going to do is we're going to place the material to have enough material out, even above this line that I just marked right here. And all this material is going to be held in between the jaws of the chuck. Okay. So in this case, what I'm trying to do is have enough material out. All right. So for instance, right there, I think that's also a safety point for us. And let's just snag it a little bit before doing anything else. And let me bring this out. So in order to, because this is just going to be like too much of a material, just pretty much in a cantilever position, we need to have some support on the other end. So the reason to have that central drill is to add our live center, and that is this component. All right. So what we're going to do is just want to place it here. I'm going to bring it all the way to this position. Okay. We're going to make sure that it's pushing in, and then locked it. Okay. So although I'm using the same lathe that I did for lab number 1, just keep in mind that this lathe, this lap is going to be done. You're going to do it in the other piece of equipment that we have over there. Okay. Eventually, we're going to have them rotated with number 1 and number 2, but they should work exactly the same way. All right. So just to check the rotation of the equipment, let me turn it on. Now let me check what's happening. I'm back. I know what happened. So although I was clicking on, we need to have the cover in position. Okay, very important. So my bad on that end. So this is working. Let's just check the rotation before we. So as we can see, the material is rotating, doesn't seem to be wiggling, so that's good. The live center is rotating. It seems to be like not giving any issues with this. Okay, so we're good on this end, right? And as you can tell, like as I'm pushing this in, it's pushing the material into the chuck because I haven't tied up the jaws. So right now I think we're good on the rotation, no wiggling, so it doesn't seem to have any issues. So let's go and now add our marks. Okay, let me pull this out a little bit and also bring this material out as well. That's our mark. It's not good. It's not good. And now that's tight. All right. So now let's double check. Put the cover. Turn it on. Again, just slowly. Let's check that it's moving. It looks just fine. Alright, so let's now turn it off just to avoid any issues. Now let's try to align the first flank of this tool with the face. So for that, we're going to do something like what we did previously. I'm going to try to get the flank of the tool of the cutter close to the face that we have right here. Of course, this is going to be a little bit more complicated than the last time for the first part of this lab, because now we don't have like the same reference. We don't have the opportunity to have the same amount of material getting there. Okay, so it seems like we are okay on this end. Let's see if we don't have any issues with the clashing of the tool with the livestock. Let me check that part, because we need to reduce that to half an inch, as far as I remember. Okay, so let's see if we make it to half of an inch. So we need a quarter of an inch in between the center and this part. Okay, we're good. So let's check it. Okay, I think we have enough room to do this. Alright, this doesn't seem to be an issue. Okay, so we might be able to get this work done. Okay, so just need to double check that part and we're good to go. Alright, so again, just double check this. Alright, so now as we did it before, just try to get the cutter to be barely in touch with the tailstock. So we're going to try just to get it closer and closer. So let's try it with some speed to check. I think now we're getting some contact. Okay, let's leave it there for the purpose of a lap. Alright? So now let's make the marks that we need. We need our first mark should be from the surface to have 2.5, to have this difference, it would be 0.75 inches that we need. No, sorry, we might need to go all the way to here, all right? So that way we are cutting initially the material from this end all the way to this end. So we need to have 2.25 inches first. Alright, so now let's make the cutter go all the way to that position. So it is almost in contact. Alright, so turn it off just in case and make this mark right there. To make it more clear, let me just bring it in a little bit. Okay, so I don't know if it's visible for you, there's a small mark over there. Let me just make it a little more. Alright, so that would be our first mark. It would be a good idea just to mark the other length, the total length, that it's 3.25 inches. So we're checking that you're seeing this part, 2.25, we're going down, and make it all the way here. Okay, we're close there. Let's also move it, the spindle, and that would be pretty much our mark for the total length. Alright, so let's bring this out. And again, part of your work for the lab is to have these calculations for reducing from 0.75 to 0.7. Okay, as with lab number one, sorry, with the first part of this lab, we're trying to get the cutting and try to avoid having like going crazy on the cutting. So, for instance, right now we have this mark right here. So if I just take, let's take 5, and just keep in mind that what we're going to see, it's initially, we're going to try to have that reference over there for our cutting. Okay, so there's two ways that you can do it. You could do it by hand, like this. And of course, that would make it very prone to how constant you can keep the rotation of this lever with your hands. Okay. And let me stop it there just to make. So as you can tell, there are some marks, and you're going to have a few questions related to the marks that you're having, like the roughness that the tool is leaving. So for instance, if you already identify like the right position where you're gonna have to end your cut, you can also use the automated feed option that you have right here. Okay, just keep in mind that you need to stop it right at the moment that it's about to touch the line of reference. So let's make it go. And we're about to get to that point, so make sure you're ready to unlock this. For instance, right there. And then you can just continue with the rest by hand. So, and that would be it. Alright, so for instance right here, you can see the difference with doing the hand feeding and then doing the automated feeding, that it's a more uniform finishing. Let's check the overall dimension that we have over here. So we are close to, and I think we are missing a little bit of material to remove. We're supposed to be at 2.25, so we're still missing a little bit of material to remove. Okay. So let's and we're still a little short on the Just checking that it's at 0. Okay, we have some debris. Okay, let's recalibrate this. That's okay. 2.25. Good there. So we're still missing a tiny little bit. Okay. So I think we are just there. Right? So the next step is bring your tool back and put it another amount of lines in. Okay, and you have to do this based on your calculations. Just again, I highly recommend you do not add like all the lines on one shot. You don't have to, because otherwise you're gonna have issues with the power of this lathe. So as with the other as with the other video and some of the operations, I'm just gonna show you the first two passes, and then I'm just gonna show you the last pass, so that you have to consider the intermediate calculations as part of your work. Okay, so the second pass, also I'm gonna do it around 500 RPMs. Let's put the lock. Alright, so, and you keep on working on this part. So there's also some comments about the finishing. Okay, as you can tell by doing the machining of the surface, you're having some surface considerations to keep in mind. Okay, and we're going to talk about this in class, how you can just sense an approximate of the roughness and compare it with a tool that I'm going to show you in the classroom. So there are some specifics of the roughness that you're going to need to check. In the meantime, I'm just doing it with 500. Of course, you can just improve the surface finishing with changing the velocity and changing the depth. Okay, so for instance, to have a better finishing, we can just do the same passing that I just showed you. Right now I did it with 500. If I do it with a higher speed, we can expect to have an even better surface finishing. Okay, but I'm going to show you that at the last passing, and that would be it for this part. Let me just jump to the last passing for obtaining the 0.7 inches in diameter. Okay, we are at the last passing. We are just like a couple of thousandths of an inch ready to get the appropriate finishing. So I'm just gonna add just one more line to the feeder on this direction, and instead of doing it with 500, I'm gonna go a little crazy on the speed and try to cut it with around 800. You're gonna see the difference on the finishing that we have from the previous operation to this one. So as you can tell, there's a very significant change on this roughness. Okay. So that is something that you need to keep in mind, and that's also going to be part of your questions for this lab. Okay. So now that you have this is a different finishing. So it's a good recommendation to try to obtain the last passing with that. You can even try like even a second or last passing without changing the diameter, okay, and doing it with an even higher speed. Of course, just keep in mind that you're going to remove like just like, let's try it with 1000. You will be just removing like a very small amount of material, but it's still having some just the last part closer, and that's it. And again, you can tell that there is a very important difference on the surface finishing. Okay, and of course you're going to need to do the comparison between your depth and so the finishing of your machine section, okay, with the table that I'm going to show you for comparison of that. Okay, so we're trying to get point back to 0.7. Let's see where we are right now. Seems like we are still out of the diameter that we need just for somewhere around 3/1000 of an inch. Okay. All right. So just keep in mind what we're going to need is still another passing, but probably just one more line or two, depending on how you identify this. And after I'm done with this, we're going to do also the same marking that we did for this position, but to have in the second step that is going to be at 0.6 inches, all right?